Hi folks, I'm back again with another experiment regarding solar. Now Lloyd suggested that I try ambient solar panels for indoors rather than general solar panels. So this is just a little experiment, and it's I tried to replicate as much as I can the way Lloyd has done it. So there is 9 solar panels in this tube, and these solar panels are 5 volts, 30 milliamps each. Okay, so 5 volts, 30 milliamps, and there's 9 of them. And then on the bottom there, you'll see there in a minute, is a LED strip. Okay, so all these solar panels are wired in series, not in parallel. Okay, and what we're going to do is I'm going to connect up the power, and we're going to get the multimeter on to see how much power it's actually producing. Okay, so I will come back to you in a minute when we get everything wired up, and I'll have the meter on, and I'll just show you the results of doing this. So as I say, all it is just a piece of cardboard with the solar panels in there. Let me see if I can show you what one looks like. This is the solar panel here. That's what it looks like, just a small solar panel. Let me take it out there. There you go. Hopefully you can see that. Just a small 5 volt, 30 milliamp solar panel. So there's 9 of them in here, and with an LED strip down the bottom. And I have a bit of shiny mirror material just to help with the actual enhance the light for the panels. So give me a minute and I will come back to you, and I'll have this wired up and I'll show you the result. Okay folks, so I have everything wired up here. So let me just show you everything to be transparent. There's the transformer. Okay, now that's set to 5 volts at 0.5 of an amp. Okay, and it's saying it's consuming 1.5 watts. Okay, so if you look down here, you'll see that the LEDs are lit up on the strip. So according to the power supply, it's using 1.5 watts at 0.5 of an amp at 5 volts. Now, if we come over, I've wired in the multimeter. So if we look at the multimeter, because the solar panels are in series, I'm getting 38.4 volts from the solar panels. Okay, 38.4 volts. So what I'm going to do is now going to change this over to see how many amps we're going to get. So give me a minute there. Okay, I've switched over now to set it to amps, and we're getting 31 milliamps. Now the panels are rated as 5 volts, 30 milliamps, and because they're wired in series, we add up all the voltages, but the amps will remain the same. So we have 31 milliamps at 38 volts. I'll just go back to show you the volts now in a minute. So we're getting 38 volts at 30 milliamps. So let's do a calculation and see. Okay, so I asked Gemini AI, if you have 38 volts and 30 milliamps, how many watts do you get? And Gemini answered saying you get 1.14 watts. Now, this is consuming 1.4 watts, but we're only getting 1.14 watts. So there is definitely a loss with the solar panels. I mean, that's not too bad. I'm quite happy with that result. you know, it's not too much of a loss. Obviously, you expect a loss, but that's not too bad considering. So I think the ambient solar panels are actually better regarding the loss factor, because solar panels generally are between 20 and 23% efficient, which is very low in efficiency. So if ambient solar panels are actually better for low light and indoors, then that's not too bad. I'm just wondering if you could get bigger versions of these ambient solar panels and see what happens. And maybe there's a way to use them where they can boost that power. But it's not a bad result as far as I'm concerned, but just to show people how it works. So 38 volts, 9 panels, 5 volts, 30 milliamps per panel, and it's taking 5 volts, 0.5 of an amp to power the LED, and 1.5 watts. So there you go, another experiment regarding solar.